A very warm welcome to the wonderful world of chemistry. मैं हूं शिशिर मित्तल और व्यास सर्टिफिकेशन की ओर से मैं आपके पास एक बार फिर लेके आया हूं NCERT सॉल्यूशंस किसके एक बहुत ही खूबसूरत और बड़े इंपॉर्टेंट चैप्टर के जिसका नाम है कोऑर्डिनेशन कंपाउंड्स। 12th इनऑर्गेनिक का चैप्टर है और मुझे पूरी उम्मीद है कि आप इसका भरपूर फायदा उठाएंगे। क्यों? क्योंकि ये सिर्फ कोऑर्डिनेशन के NCERT के मामूली वीडियो सॉल्यूशन ही नहीं है। इन क्वेश्चंस के बहाने से हमने पूरे कॉन्सेप्ट्स डिस्कस करने की कोशिश करी और कोशिश करिए कि जितना आपको इसके थ्रू मिल सके मिल जाए। आइए शुरू करते हैं। Explain the bonding in coordination compounds in terms of Werner's postulates. Now, Werner was the first extraordinary scientist, inorganic chemist, who actually explored and gave a very scientific and a fairly accurate theory for coordination compounds. So, his work is primary and path-breaking. And how did he start? Actually, he did a lot of work, but then, as our NCERT mentions, a few ideas which he proposed and which he gave and which are useful are as follows. Werner talked about primary and secondary valencies. Why? Because before Werner, people used to talk about, just a concept of valency, like why should a substance form a bond? They said that they had to satisfy the valencies. That was the concept of valency. Now, if you have if you have something like potassium cyanide and if you have ferrous cyanide, these are the compounds in which valencies are already satisfied. So, if you put them together, would they react? Actually, they react to give you K4FeCN6, which is a new complex compound. And since they could not understand what is happening, they said this is a complex. Nowadays, we call this a coordination compound. So, the concept of valencies for attaining stabilities was seemingly at fault. And Werner upgraded and modified this by supposing or suggesting that there might be two types of valencies, primary and secondary. What are these? Just take a look. In coordination compounds, metals show two types of linkages, that is primary or secondary valencies. The primary valencies are normally ionizable and they are satisfied by counter ions, not just negative ions, counter ions. Counter ions means if the complex species has a positive charge, then negative ions. If it has a negative charge, then positive ion also. Like in this case, the coordination entity has a negative charge. So that is satisfied by positively charged potassium ions. So that is the primary valency. Now, what is secondary valency? Secondary valency is something which is non-ionizable. If I dissolve K4FeCN6 in water, it releases potassium ions, K plus ions, and it releases FeCN6 4 minus ions. So they are, in that sense, primary valencies. But if you just look at the portion within the square brackets FeCN6 4 minus, you find that these valencies are not ionizable in the sense 6 cyanide ions will never leave ferrous ion. Ferrous and cyanide always are very strongly bonded and they stay together. So that is why they said their secondary valencies are non-ionizable. Okay. And anything special? Yes. They are satisfied by neutral molecules or negative ions. Now these neutral molecules or negative ions these days are called ligands. Werner did not use the term ligands, but he meant the same. The secondary valence is equal to the coordination number and it is fixed for a metal. Let me warn you, Werner himself did not use the term coordination number, but he just used the term secondary valency. And what Werner used to call secondary valency is now, after roughly 100 years, we now call this a coordination number. Fine. And that is fixed for a given metal ion. Yes, that becomes fixed for a given metal ion. The ions or groups bound by the secondary linkages to the metal have characteristic spatial arrangements corresponding to the different coordination number. What does that mean? Not just this, Werner also talked about the geometry of ions. Through various experiments, he could conclude that these secondary linkages, yes, these secondary groups or the so-called ligands nowadays that we call them, when they are linked to the metal atom or metal ion, they are arranged in the form of a very special geometry. And that geometry depends upon what is the number. Say for example, if coordination number is 6, the number of secondary valencies is 6, then the geometry is octahedral. So that way, so this is the meaning of the fourth point, and these were the points suggested by Werner in his fundamental theory.